Today we're going to be making a heat-triggered fan using an Arduino and some different components. How this is going to work is we're going to set a temperature, and when the temperature rises above that, a motor is going to turn on, acting as a fan. So the first component we're going to talk about is a motor. You see here we have a positive and a ground wire that run into it, and inside the housing is a coil, and when the current runs through the positive to the ground wire, it's going to power up that coil, which is going to cause the spindle up here to start spinning and operate like we're used to a motor running. Here is the diagram that will be used in a schematic. We'll look at that a little later in the class. The next component we're going to look at is a diode. The specific model we're using today is a 1N4004 diode. There are two sides to a diode. There is the cathode, which is marked here by a little lighter line. Every diode's going to look like that to show you the cathode side, and the anode. The cathode side is the negative side, and the anode is the positive side. And the way a diode works is it's like a switch a gate that works in one direction. If we have the current coming in from the positive, flowing through to the negative, the diode will allow current to flow normally. But if we have it set up so that the current is coming the opposite way from the negative to the positive, it will block the current from flowing through the circuit in that part. The way we're going to use it today is to protect our motor, and we'll get into that a little bit later when we're looking at the actual schematic. Here's the symbol that will be used in a schematic diagram. It's a triangle with the line. Just remember, the line is the cathode, the negative side, so we don't get that switched, because if we have the diode backwards, it's going to do the exact opposite of what we want it to actually do. The next component we'll look at is a transistor. A transistor is basically a small switch that is operated by a very small current, but allows us to use a very large current. There are actually a lot of different ways that you can use a transistor. It can also amplify current, but today we're using it as a switch. And the way that works is we send a small current to the base right here, the middle leg, and that will allow current to flow from the collector to the emitter. And the reason we need to do this is because with components such as the Arduino, it can only use a small bit of current directly from one of the pins, and it takes a large amount of current to power the motor. So if we just directly power the motor from a pin, we would basically blow up our Arduino, and obviously we want to avoid that. So we send a small current from the pin to the base, and that allows a large one that's hooked up to the larger current supply to flow through, and that will power the motor much more effectively for us. Just for your reference point, if you have one of your transistors handy, this is the flat side of the transistor, and it is rounded on the other side, so make sure once again that you're getting your components oriented correctly so that you're not putting it backwards, because if you have it backwards, the current won't flow from the emitter to the collector. This is the symbol that's used in a schematic. So basically, you can look at the base here, almost think of it as a small switch that's being pushed in, and when it does that, it closes this switch, allows the current to flow through the collector and out through the emitter to ground. And the final component we're going to talk about today that's new is the TMP36. It's a temperature sensor. It's in the same kind of packaging as the transistor, so make sure you don't get those mixed up. As you can see on here, you should be able to read TMP36. And how this works is it has a small temperature sensor in there. There is a positive voltage leg. It's connected to the ground, and the voltage is flowing through there, the current. But once the temperature rises or decreases, this third leg sends out an analog voltage that we're going to connect up to an analog pin on our Arduino. And as the temperature rises, our voltage will also rise, and as it decreases, our voltage will go down, and that will allow us to actually determine the temperature in the room at the time. Here's a basic symbol that's used in a schematic. You'll see a lot of different just boxes like this when you're getting into very simple integrated circuit type designs. You'll have your positive voltage will come in here, your ground will be connected to 0 volts here, and then you'll have your line coming out. That's your analog voltage that's connected up to however you're going to read it. So here we have the actual full schematic that we're going to use. You'll see over here, just have our battery, our 9-volt battery. Like I said, that's hooked up, running through here to our positive voltage, and our ground's going to the ground of the battery. And then here we have our analog voltage. It's going to change as we go along, and it's running into analog input A0 on the Arduino, and that's going to read the voltage as it goes up and down. For our other part of the schematic, we have the motor. That's what we want to turn on. That's operating like our fan. That's all a fan is. It's just a motor with blades on it. So right now, the fan is going to be, the motor is going to be running through the transistor, and when it's off, when there's no current coming out of D2 here, it's like the switch is open here and the circuit just isn't working. And then when we turn on D2, it's going to turn on this switch, closing this and allowing that current to flow through. And then our motor will actually run, acting as a fan. And we just have a small 220 ohm resistor here. That just protects the transistor from getting too much current and exploding. And here, up in the top right, we have that diode we were talking about. What will normally happen is the current will be flowing in one direction, and that will be blocked. It will be flowing this way, and that will be blocked from going into the actual Arduino itself. But because we have a coil, which is an inductor, and that's a complicated subject for another day, but basically anytime you have an inductor, which is anything with a coil, when you turn it off, it's going to send a large amount of voltage and current back in the opposite direction like that. So what would happen if we didn't have a diode is it would go back through our transistor and into our Arduino, and it would destroy our Arduino. So to avoid that, we have our diode here, and it will take all that current that comes out of it, and it will just short it through here until that goes away. So that way we just put that in there to protect our Arduino, and that's all that's doing. So now that we have our schematic and we have an understanding of what's going on, we can start putting the actual circuit together. So here's the layout. So you got your 9-volt battery, your Arduino. This right here is our TMP36, our transistor, our 220 ohm resistor, the diode, and our motor. We have some of these lines here. Just ignore those. They'll go away when we actually start routing the circuit. They're just showing connections that we haven't routed. So what we're going to do is to actually just, with our breadboard, every time we do this, if you can see here, there's a blue line and a red line. The red's going to be our positive voltage and the blue is going to be our ground. And the way these run is this whole part of the breadboard is connected this way for both the positive and the voltage. And it's the same on the bottom. So what we do is we connect them from here to here and both of our positives together so that we can just connect our battery once to the side, and we can actually use power and ground on both sides. Now for the rest of the breadboard, we haven't really gone over this before. Each of these lines is going to have 5 connected pins, so whenever we have anything connected in any of these 5, they're all connected together. This part here is a break, and then we have another 5 of them through there. So that's how the basics of how we're going to set up a breadboard. So after we have that, we're going to actually start connecting our battery. We're going to take our ground wire, the black lead, and it's going to go through to our ground, and our positive is actually going to go up to the voltage in on the Arduino, and the Arduino can take a 9-volt battery, and what it can do is output 5 volts at this pin, and that's how we're going to connect 5 volts to our board, because everything else we're running on our board is running on 5 volts. And then we're just going to take the ground pin from the Arduino and connect it up to the ground on the breadboard, and at this point the Arduino and the 9-volt battery are all connected up and providing power to our board. Next we're going to hook up our temperature sensor. you can see here, we've got the 5 volt, it's just running up to the 5 volt leg, and the ground is running to the ground on the breadboard. And then our middle one, which was our analog voltage out, is just running up through here, and you can actually just use one pin directly from here to A0, and that's hooking in, and we're going to be able to read that analog voltage as it changes. We're going to start hooking up the actual transistor itself. See here, we have our ground is connected up to our emitter, and then we have pin 2, digital pin 2, that's going to be our switch that when we turn it on, it's going to run through this resistor and up into the base, which is the middle pin. Once again, make sure you have your transistor oriented the correct way with the round side and the flat side. And then the emitter is not actually hooked up to 5 volts right now, but we're going to get to that shortly. It's running to the one side of the diode, which once again, make sure you have your diode go in the right way, get that line set up so you have your cathode and anode correct, and to one of the legs of the motor. And then the thing we're going to do is we're going to take our 5 volts from the board, we're going to run it up, so that's now running the whole way through that transistor from 5 volts to ground, and it's also connected up to our motor, and then everything is connected through, so the diode is also protecting it. At this point, our circuit is set up and ready to go, and we can get into the code and start talking about that a little bit. Then we can get our circuit running. So now we have our circuit set up, we can start talking about our code. We're going to set up a couple of variables right off the bat. They're constants, so they're going to stay the same throughout the entire code. The first thing we're going to have is our sensor pin. We're going to set that to 0. So we're saying our sensor pin is our analog voltage coming out of the TMP36, and that is going to be pin 0. The next thing we're going to have is our relay pin. That's the one that's going to turn the transistor on and off, and we're going to set that to digital pin 2. So whenever pin 2 turns on, that's going to turn on the transistor. And then the final variable we're going to have here is temperature threshold, temp threshold. We've set it for 20 degrees right now. So if we want to make this circuit turn the fan on or off at a different temperature, what we do is come in and change that 20 to whatever number we want. We can set it to 10, 30, any number that we want it to go for. We just change it there. So now that we've established those variables, we're going to move into the setup. The first thing we're going to do is our serial begin. What that is doing is connecting the Arduino so that it can actually send out readings to our serial monitor, so we can actually read numbers directly from the Arduino on our computer. The next thing we're going to do is our pin mode. That is taking pin 2, which is what we'd set pin 2 with relay, and setting it as an output. Pin mode can either set a pin as an input where it's receiving a signal, or output where it's putting one on, one out. So obviously we want it to be out so that it can turn on the transistor and operate the rest of our circuit. And then digital write is just choosing whether we set that pin 2 low or high. Low is 0 volts and high is 5 volts. So we're setting it low so the relay and therefore the circuit is off when we turn it on initially. We've done our setup now, so now we can move into our loop circuit. Our loop part of the code, that's the part that will just keep running over and over again until we turn our Arduino off or the battery dies. First thing we're going to do is we're going to get a new variable reading, and with that we're going to get our analog read, which is the full range from 0 to 5, as opposed to a digital read, which is just 0 or 5. Analog read, we can have anything 0, 1, 1.3, 2.5, any number, and we're going to read that from our sensor pin, which if you remember we set at 0 up here, so we're getting an analog reading from analog pin 0, and that's what our voltage and our temperature sensor is giving us. At this point we're going to convert that. We're just going to do some math with it just so that it works with the Arduino. We're going to take that reading and multiply it by 5 so that our Arduino reading is actually accurate. I'm going to take that voltage variable and divide it by 1024. The 1024 is coming from the amount of accuracy that the Arduino can have. It's an 8-bit processor. That means it's 2 to the 8th power. So that's 1024 readings that can get. So now we've come to this point previously, and now this is the new part. What we're going to do is we're going to serial print that voltage reading we had, and that's going to send it to the monitor on your actual computer. It's going to give you the number of the voltage, and then after that we're going to serial print volts, and because it's got the quotation marks either side, it's going to print out the volts. So the reading you'll get on the computer is whatever number your voltage was, volts. And now it's going to actually go out, and we've got a little calculation here that talks about here that's going to convert that voltage to an actual temperature. So now we have that, and we're going to serial print it here. So the next thing we're going to get is, after it says however many volts it is, it's going to say however many degrees it is. And the next thing we're going to do from there is we're going to make that decision whether or not to turn the motor on or the fan on based on the temperature. So if our temperature that we just read is greater than our threshold, which remember we set at 20, it's going to digital write the relay high, which means it's going to turn on the transistor, which will turn on the motor. And then else we're just going to leave that relay low. And then it's going to delay 1000 milliseconds, which is 1 second, and then it's going to go through that loop at that same starting point. It's going to read the voltage, it's going to convert that to a temperature, and then it's going to make that decision. If it's got past that threshold temperature, it's going to turn the relay on. If it was already on and then it's dropped back below that 19, it's then going to write it low and turn the fan back off. So anytime it's above 20, every second it's going to get that reading, and it will stay on until it turns off, and vice versa. And this loop will just keep running and running until you go ahead and turn off your Arduino or the battery runs out. So that's everything we need to do. So at this point you've got your circuit, you have your code, you're just going to hook up your Arduino, load your code onto it, go ahead and turn your circuit on, and it should run as planned. Thanks.